Alright, you were listening to Into the Absurd, episode number 11 with Andy Johnson. He is a physics student at the University of Idaho. So we're going to get into some topics that might be a little advanced, but they're going to be fun. So what's going on, Andy?
Thank you for having me, Greg. Not a lot, just right now, just a lot of schoolwork. I mean, as you know, like, especially with, so COVID's kind of screwing us up right now, you know? It's like, especially with all the classes that we're taking, I'd much rather it be in person than online. I'm very lucky, though, because this semester I got 2 in-person classes and the rest are online, but it's like I'm still going to campus every day instead of just sitting in my apartment for 5 days in a row, you know? So it's good to actually have, like, some social contact now. It's good.
I think, who was it? I think it was Shakespeare who wrote most of his plays during the plague, right?
Yeah, I heard about that. I don't know if that, I've never really, like, looked into the biography of Shakespeare, but that's what I heard, too. Which, like, makes sense, right? You don't have a whole lot else to do, rather than just, like, use your brain and write down a whole bunch of stuff. Make history, you know, change theater forever.
Yeah, well, he also changed the English language forever.
Yeah.
I think he invented, 10,000 words or somewhat.
Oh, did he really? Yeah, I don't know.
I don't know. Someone can fact check us on that, but
I'd believe that, though, because like his plays became so prolific, right? It's like I definitely understand that people like would pick up what they're saying in the plays and use it in their everyday speech. I mean, we do that with movie quotes all the time now. So imagine back then when there was only like one person making movies and those were all that you saw. It's like it makes sense why those would, like, the language and that would become part of our language. Yeah.
So this is a bit of a diversion from Shakespeare, but so Isaac Newton, he invented calculus, but really he didn't, right?
Yeah, well, I stay away from saying the phrase "we invented math" because I don't think we invented math. I think math was discovered, and this is, I think, probably a really good topic to get into now.
Yeah, was it discovered, or did we, is the universe mathematical in nature, or did we invent math?
Yeah. And this is a topic I've discussed with a lot of people. I've discussed it with physics professors, math professors, biology students, and then my girlfriend and everyone. I always bring this up to because I want to know what they say. And the biggest argument back against it, the biggest argument for we invented it is, well, we invented like 1 and 2 and like the number system, you know? And I say, yeah, we invented the notation for it, right? It's like when I write down the number 1 on a piece of paper, that is a uniquely human thing. That is something that we have done. We have agreed that this number 1 on the paper is 1. It's just like language. We invented the notation for our language. But the consequences of writing down these numbers, I don't think is something that we invented, right? Because we say 1 plus 1 equals 2. Well, 1 plus 1 always equaled 2. We just had to find it. We just had to look at the numbers and put them together and say that they equaled 2. Now, the words, the notation and all that is uniquely human. But I think all the other consequences of math were discovered, not invented. So I think Newton, to get back to your question, I think Newton discovered calculus after playing around with it. It was already there. He just needed a way to notate it, to write it down. Mm-hmm. Yeah.
Yeah, but I think what adds on to that point is that there was another physicist, I think, was it Leibniz?
Leibniz, yeah.
Leibniz, was he the other guy who discovered calculus?
Yeah, so Newton and Leibniz pretty much at the same time, independently of one another, were discovering calculus at the same time. And the notation that we use in calculus, the derivatives, integrals, all that stuff, that is mainly Leibniz notation. There is some Newton notation, but Newton, in his book that he wrote, the Principia de Mathematica, which is like the book that introduced physics to the world, that introduced calculus to the world, that book was pretty much a stream of consciousness. It was very difficult to read, and even like to this day, it was written hundreds of years ago, so it's Old English, you know. But it was just hard to follow along. He's using all this weird notation that just kind of pops out of the blue. He doesn't explain it at all. And Leibniz was a lot more like concise and clear. And people just it was easier to read Leibniz. But technically, Newton did discover it first, but only by a couple years.
So Newton was he was in some other realm when he was...
Yeah. Yeah. And actually, I think that also happened during the plague, too. Newton, when he was discovering calculus, was in his home in like which was on a countryside. It was this little, almost like pretty much their equivalent of cement house, very small. And he was sitting in his room, which is I don't know, maybe like a third the size of this room. And he just sat at his desk for years and just was writing all this down. And that was also when he started to discover optics, because his window wasn't really a window. It was a slit in the wall, like what you would see in a castle, right? And it was just coming in and refracting off of like the metal in his room or any of the glass hardware that he had in there. And it would split off into different colors. So he was like, oh, this is interesting. Why is it doing this? And so he started to look into that. And it all happened in that one room, this little like 10 by 10 space where this man changed pretty much the world forever.
Huh.
Yeah. Yeah, it's crazy to think, right?
Yeah, I mean, I think isolation is an important thing to have in one's life in order to have these creative ideas, such as discovering rainbows. Well, discovering why rainbows exist. Right?
Yeah.
And then taking that knowledge to let us know, later on at least, why the universe is expanding.
Yeah. Yeah, exactly. It's like the same math discovered 400 years ago is the stuff that we're still using now. And that's why, that's another argument that I use for why I believe that math was discovered, not invented, because inventions don't always work, right? It's like I can invent, I could have been the guy who invented a coffee maker, right? Mm-hmm. But that wouldn't have like an impact like 400 years down the road maybe. But it's like, even if society is completely destroyed and all of the books are wiped away, the next generation of whatever life form is on Earth or maybe on a different planet will still find the same sciences, will still find the same truths in mathematics. We were just the ones to do it first on our planet, you know? There might be another civilization out there that has discovered it, but, you know, we don't know that right now.
Yeah.
Yeah.
I think it was the Aztecs who discovered the concept of zero.
Yeah. It actually was that's an interesting point. It was a surprisingly long amount of time before zero came into play in the world. And because, like, try to explain that to someone. I mean, it makes sense now in our society because we've been using zero for so long. We were born with the notion of zero. It was easy for us to pick it up, but you're with these people and it's like, okay, show me 0 cows, you know? It's like, well, clearly I can show you 0 cows because I don't have 0 here, but it's like, how do I formalize that and bring that into the accounting that they did? Because that's really how math was brought into society, is because farmers, when villages were producing food, they needed to trade with other villages and they needed some sort of system for accounting for the quantities that they were selling. And that's where math really kind of came into play. But it's like, why would you ever use 0 there, you know? It's like, why would I ever use 0 bundles of barley, you know? So.
And then we came up with measurements, measuring lengths and depths and volumes. And then I think all that really came into play when we, because during the time of the Greeks, that's when a lot of our mathematical theories just came into existence, at least, right?
Well, what do you mean?
Like Pythagoras.
Yeah, he was the one to start like saying that. And it's an interesting point you bring up too with like measurement and stuff like that, because the whole point of measurement is to kind of take the human element out of it. It's like, yeah, humans are still making the measurement, so there's always going to be like inherent human interaction there. But you know, humans are inherently like, it's easier for our senses to get deceived, you know? Like in chemistry, there's an effect called the Parallax Effect. And it's actually not just in chemistry. It's in a lot of places, but it's seen mainly in chemistry, where if you have a beaker and you fill it with some fluid, the air pressure will push down on top of the surface of the liquid and it'll cause this little like bowl shape to come to the top of it. And that's called a meniscus. And then the way to truly measure that is you have to read at eye level the bottom of the meniscus. Wherever that reads, that's how much volume of stuff that you have. Mm-hmm. But if I look at it from a different angle, it could look as though the meniscus has either raised or lowered, so it can throw off the amount of like material that I'm going to write down on my lab report, and then that can mess me up later, you know? So measurements and tools kind of try to take the human element out of that, where it's like, okay, I have a scale and I put a 50-pound thing on the scale and the scale tells me it's 50 pounds. I don't say it's 50 pounds because truly, like, you could pick something up, and I mean you, because you're pretty strong. You probably have a better idea of what 50 pounds is than I do. So it's like you could pick something up and say, oh, this is probably 50 pounds. But the tool will tell us specifically, like, no, this is 50 pounds. It takes the human element out of that. So we can make more precise like measurements, and then we can use that later when doing pretty much anything else.
Do you think over time we will get better at measuring things?
Oh yeah, well I mean we already have, right? I mean, what did we use before? The furlong was a unit of measurement that I think it was the Egyptians used. Yeah, the furlong. It was the length of a man's forearm, right? It's like that's a very like non-precise unit of measurement, right? Because everyone's forearm is a different length. You know, I mean, it's in general maybe about like a foot. If you're really tall, maybe like a foot and a half or something like that. Yeah, but it's different for everyone, right? So we went from there to now we have a standardized ruler that we use. At least in the United States, we have the foot, you know. But even when we buy, this is actually a whole branch of science called instrumental analysis, really understanding how precise an instrument can measure. Because
instrumental analysis.
Yeah, you're analyzing the instruments that you use, it sounds kind of stupid, right? But it's really important, especially with chemistry, when it comes to producing pharmaceutical drugs, right? If you get the wrong ratio of things mixed, you can kill someone. It is a very important thing. And when I'm analyzing something, say we get like a meteor lands on Earth, we need to know that the instrument will be giving us an accurate reading on whatever it is, because that can completely change how we interpret the universe. It's a very important thing, but it's one of those things that you just don't really think about or you hear about. It's like, oh, why would I spend time analyzing my instrument? But
well, why wouldn't you?
Exactly. But I mean, like, we normally wouldn't, because most people in day to day, they don't need to know why an IR spectrometer is like how accurate is that, you know? But it's like with people who are actually doing the studies, they need to know that stuff because that really can affect their progress.
So so with Einstein's theory of relativity, that allows us to have more accurate GPSs, right? Because we know that what is it? Time moves slower.
Yeah. So relativity is a very interesting phenomena, and I'm just starting to learn about it, like, really, because I mean everyone hears about relativity through popular media, right? Like everyone knows that Einstein did general relativity, but no one knows what general relativity actually is, right? We just know that that's one of the things because everyone knows the phrase like, oh, you're an Einstein or whatever. But yeah, relativity tells us a couple different things, and depending on how you're looking at it,
everything's relative. Is that what that means?
Which is funny. It's like, yeah, it's a really stupid thing to hear, and even I still hate hearing that, but it's absolutely true. Everything is relative, but it's also just like, oh, come on, man. But there's one concept called time dilation, where pretty much what it says is anything that moves experiences time slower at a different like to an outside observer. And one really good explanation of this that I still will go to when I'm trying to explain to someone this is in the Sonic the Hedgehog movie. When that came out, there's a scene where Eggman shoots all of these rockets at him. Well, Sonic like pretty much pauses time and he starts running around and he starts playing like the drums on these missiles because he's moving so fast that to him time is essentially stopped, but to everyone else looking at him, time is going its normal speed, but he's just moving incredibly fast. That's what time dilation is. So if I start shooting on a rocket ship away, going near the speed of light, to me, the universe will go by slower. Everything will be dilated. But to you, looking at me, you'd be like, wow, Andy's going the speed of light. Like, that's pretty cool. So that's one thing that relativity says. And back to your question about GPS, another thing that relativity tells us is that gravity also affects time, which is essentially like wherever there's stronger gravity, time will move slower, I believe. This is one that I'm a little more fuzzy on because I haven't looked too far into it. But it's essentially like, even if I'm in a home, a clock on the first floor will run slower than the clock on the second floor. But I mean, really, we're not going to notice that because it's such a minute, like infinitesimal amount of time that it's dilated by. But it's real. It's there. It is relative. And this happens everywhere. So yeah, with GPSs who are hovering thousands of miles above the Earth, they're going to experience a lot less gravity than us down here on Earth. Mm-hmm. And that difference is more noticeable in the long run. You know, if they've been up for 20 years, their clock is going to be running different than our clock. So we have to constantly send them signals to reset their clock pretty much to make sure that we're all on the same time. Because the time can also really affect your GPS, right? It could also be like, hey, it's going to take you 5 hours to get to this place where it's actually maybe 10 minutes away. You don't actually know. Mm-hmm. So yeah, Einstein's relativity has helped in that regard.
It also requires it needs to have accurate time in order to know where your location is too, right?
Yeah, exactly. Because if it's 6 o'clock in Idaho, but the satellite doesn't know what time or where I really am, it could say, oh, well, maybe it's 12 o'clock in New Zealand, like that could throw you off. I mean, there's a lot of other factors that go into GPS that has also like helped it too, but relativity is one of the things that when GPS was kind of being, well, I mean, GPS was developed after Einstein, right? Because Einstein did it in like the 40s, and we didn't really have satellites then. But it's one of the things that we didn't really put the pieces together until we started to see like a difference. And we're like, oh, okay. And I mean, there's even an experiment that they did. They took an atomic clock, just like an incredibly precise tool for measurement of time. There's another reason why we need instrumental analysis. And they put it on a plane with this guy and flew him to New Zealand, and then had one guy in London. I think those are the places I might be getting that mixed up. That's not important. He had the same atomic clock, but like at another time. And when the guy landed in New Zealand, because when you're flying in a plane, you're higher up there, time's going a little bit faster than us down there. His was about, I think it was like 100th of a second faster, which isn't a lot, but that proves that relativity is real. Like it's there, and it's a measurable effect.
Did they have the same clock?
Not like the same physical clock, like
But
they
the
had
same design?
Yeah, and the way that those work is that there's a little crystal of cesium in there, which is just this metal, and the cesium atom vibrates at a very specific frequency, at a frequency that's specific to that, and that's actually how we have defined the second. It's some ridiculous amount of vibrations. It's like 10 to the 23rd vibration, so incredibly fast. But our instruments now are so sensitive that they can pick that up.
Wow.
But I mean, time dilation doesn't just affect a clock, it affects everything, all the matter with it too, including the vibrations of a cesium atom. So if you put it on a plane and send that around the world, even the cesium atom will be vibrating a little bit faster. Yeah, it's this crazy idea, but it's real and it's measurable, and we've been measuring it for 50 years.
So what frequency is your brain vibrating at right now?
Oh, I don't know, man. I mean, there's a lot of vibrations that happen in like at that scale. It's like, well, I mean, you have like macro scale, like classical vibrations. Like if I move my head left to right like this at like one like cycle per second, then it's a frequency of 1 hertz, like one thing per second. But it's like the frequency at which my neurons are firing are much faster, right? Well, the neurons fire with electrons, and electrons exist in this weird state where they're both kind of like real and not real, and they flutter between that even faster. So it's like, that's a hard question, and I unnecessarily analyzed that, but
Yeah, I mean, it's crazy how every single thing that you see in this room on the atomic level is vibrating at an unimaginable speed.
Yeah, and I mean, one of the other vibrations, and one of my favorite descriptions of it, is heat, right? Heat, when we think of heat energy, like, what is heat when we're talking about like a physical sense? Well, if I have a cup of hot water and it's hot, right? That just means that the little water molecules are moving around really fast. They're jiggling, they're vibrating super quick. So when you really think of temperature, and I ask someone, oh, how hot is this thing? I'm really asking, how jiggly is this material? I could essentially just ask, like, oh, how jiggly is this cup of coffee? And I could be like, oh, it's about 90 degrees. Like
Yeah.
that's a fair question and answer.
Do you think it's possible that on the atomic level, that we could apply Einstein's theory of relativity to quantum physics?
Well, that's what they try to do, but that's kind of the that's one of the big questions right now. And if I had an answer for that, I'd be winning a Nobel Prize, because one of the goals in physics, obviously, is to create the grand theory of everything, one big unified theory. But there's so many different branches of physics. We have classical mechanics, which deals with what we deal with in the real world. When I drop a ball off of my desk, that's classical mechanics. But then when I zoom down onto the really, really small scale, that's quantum mechanics, and they play by two very different rules. And that's why it was so bizarre when we found out about quantum mechanics. It's like, oh, how come this world, this subatomic world that makes up the macroatomic world, like our macro universe, that plays at a completely different like set of rules than what that does. And general relativity is another branch of study with that, but there's no connected link between all of them yet. There isn't one solid theory. There's actually, what they're trying to find right now is the theory of quantum gravity. that is the link between quantum mechanics and relativity, because like I said earlier, relativity can also depend on gravity, and gravity is a really weird thing. But this quantum gravity is like, how can we quantify gravity? What does gravity exist at on the smallest possible scales? Because if there's gravity on the smallest scales, then relativity will apply. But so far what we're finding is that there's not gravity on the smallest scales. We don't know how to quantify it. And that's just one of the problems that we have right now. One of the things that we should be looking into, you know?
So I was thinking if these, this is just a thought, I mean, it's wrong. It's a wrong thought, but I was just thinking if these atoms are moving extremely fast, like they're vibrating extremely fast, doesn't that mean that time would be slower for them?
Oh, that's a really interesting point that you bring up. Well, I mean, so movement is relative, right?
Yeah.
That's how we have to define it. Because I can say something is moving at 50 miles per hour relative to what? How can I quantify how fast it's going? And what's really weird when you think about it is you, as an observer, you are your own reference frame. You go through life, and we're human, so the world has said, like, we've evolved that when I walk through this room, you know, my body knows I'm walking through the room. But really, your reference frame is not moving. The world is moving around you. It's relative to that. But if I'm standing on a sidewalk and I see a car go past me at 50 miles an hour, to me, the car is moving 50 miles an hour away from me. But if I'm in the car and I drive past the guy on the sidewalk, the guy is moving 50 miles per hour relative to me. It's dependent on the frame.
Isn't the speed of light also relative? Like if...
Ooh, that's a good question.
If, for instance, right here, I were to shine a flashlight, it would go at 3 million meters per second, right? But if I were to be moving at the speed of light and then I shine my flashlight, would my flashlight then be moving at 3 million meters per second relative to my speed?
Yeah. So light moves at 300 million. So like even more.
300 million.
Yeah, 3 times 10. Well, it's really like 2.99 something, but it's essentially 3 times 10 to the 8th, which is 300. Yeah, it's fast. And to answer your question, yes, it will always move that fast. And that's one of the consequences of relativity. That's what Einstein discovered, that the universe will always make sure that the speed of light stays constant. It will never slow down and it will never speed up. And there's some really wacky consequences because of that. But yeah, no matter what reference frame you are in, and no matter how fast you're moving, light will always be the same.
Yeah, so I guess that's why a lot of observations of the universe probably aren't, well, they definitely aren't time accurate. You know, we're not seeing...
Well, okay. Go ahead.
Well, what I mean is, you know, like you look out on a star, and if it's 100 light years away, then we're seeing what it looked like 100 years ago.
Yeah,
right?
yeah.
But if that star were to be moving away from us, then it would, like the red shifts and blue shifts?
That's what I was going to talk about. So, yes, the speed of light will stay the same, but the energy of light can change. And so what Greg just said was this concept called, well, that's really the Doppler effect.
Yeah, the Doppler effect.
Yeah, it's just the Doppler effect is a very generalized is a very general concept, and then redshift and blue shift is a consequence of that. And so the Doppler effect, as you know, it's like if I'm standing on a sidewalk and there's a police siren coming at me, I'll hear it as like this high frequency, like it'll just be a higher pitch. And then the second that it goes past me and starts going away from me, it'll drop its pitch, and now it's a little, yeah. Same thing will happen with light, because light is also a wave, just like sound waves, so it follows this Doppler effect. And if something's moving away from us, then it'll drop in frequency, just like it'll drop in sound.
Because the wave of light stretches out.
Yeah, exactly.
So then it shifts to red.
Yeah, and so on the color spectrum, to our visible eyes, red is at a lower frequency than blue is. Or I guess violet, technically. So violet's like a higher frequency and red is a lower frequency. So to contrast that, if the star or a galaxy were moving closer to us, it would be blue shifted because it would be a higher frequency from where it normally is. And this is another fun thing about relativity. This still happens at our scale. You and me talking here, if I move my hand closer to you, my hand has a blue shift, but it's so minute and imperceptible that we just don't see it, you know? And it's actually like there's this joke that if, I don't know the actual speed, but it's like, oh, if you ever want to run a red light, you just need to be going like 16 million meters per second so that the red light blue shifts to green, and then you can just run past it because you'd be like, no, officer, to me it was green relative to my speed.
Yeah.
And then someone posted that on Twitter, and police department like responded. They said, don't do this.
Wow.
Yeah.
So what would you do if you could meet Sir Isaac Newton?
Oh, I don't know.
Would you, or do you think it'd be too stinky?
Well, it'd definitely be too stinky. But I feel like Isaac Newton wasn't very a socialite. Like, he didn't, I don't think he really was a person who was fun to have a conversation with. I don't know.
Sounds like my kind of guy.
Yeah. Well, I think at that time, well, if I were to go talk to Newton with everything that I know now, I would blow his mind, because math and physics has progressed so much past the point of Newton. Because Newton really worked on classical physics and only up to a certain point, Because, I mean, he was one dude back in the day, he didn't have that much time to discover everything pretty much, right? So I can go back and talk to him about even more advanced mechanics and blow his mind. But I still don't even think that, I think it would be a hard conversation to have with him about just, like, even him. Because to him, he just discovered this new thing, and people were very hesitant to pick it up for a while, Like, it wasn't just like, he didn't just release the Principia de Mathematica and then became famous. He became famous posthumously, or however you pronounce that word, after he died.
Posthumously.
Yeah, he became famous after that. So I don't even know if he...
There happens to be a lot of people.
Yeah. A lot of mathematicians. Nietzsche. Yeah, exactly. Like Nietzsche, pretty much any philosopher, really. I mean, there are ones that are alive now.
Yeah, they became famous during their time. Well, I remember seeing this one thing. This guy said that most philosophers actually became famous before they died. But the thing is, I feel like there's a lot of people, like the really famous ones, didn't actually become famous until after they died.
I mean, yeah, look at Kant, Kant is personally my favorite philosopher because he dealt with a lot of metaphysics. Yeah. And metaphysics is, the philosophy of reality. And me being a physics student, I feel like I have this natural affinity towards it. So I love Kant and I love what he says. But, well, even you think about it now, in our day and age, philosophers now have it so easy because they can easily publish a book and it's sent out to the masses, go on social media platforms and talk to people, get their name out there. That didn't exist in Newton's time or Kant's time. They just had to go pretty much word of mouth until everyone read their book. And then printing was slow back then, getting it published was kind of difficult. It was this whole nother process. So it's like, yeah, they're like the modern day philosophers that exist right now in this day and age are a lot more famous than the most famous philosophers were in their day and age,
Wow.
Yeah. I mean, yeah, but there definitely were philosophers who were known when they were alive. I may be butchering this, but I think it was Hume and one of the other political philosophers, but they kept like taking stabs at one another, like through correspondence and publishing things. So like Hume would release something, and then this one guy would create a response to that, but then he would create a response to that response, and it just kept going on. It's like that would only happen if they were already an established philosopher,
So do you think we're also discovering philosophy in a sense?
Yeah, now that's kind of an interesting question. So, with math at least, that's a very specific case. But philosophy is very generalized. It's very abstract. So, I think in a way, we kind of are. Well, okay. So I really think, and this is kind of metaphysical, that your reality is based on your own experiences. And this is a very Descartesian philosophy. So your unique reality, how you experience the world, is different from mine because we've had our own experiences that lead up to this point, So that means that we think about things completely differently. When I think of a concept, it's this abstract form in my mind that I can never fully 100% explain to you purely just because of the limitation of the English language. If you could see inside of my mind and know exactly what I was thinking, then I would no longer have these unique thoughts, these unique experiences. At that point, you would be me, but you're not me. So I have my own unique thoughts. So philosophy, I think, is this kind of attempt for us to take these abstracted forms that exist in our mind and try to bring them to light so other people can see it. I can try to explain relativity to you, but how you think about relativity is different than how I think about relativity, even though we agree on major concepts. And the same thing with calculus. The way that you perceive an integral is different from the way that I perceive an integral. So I'm not sure if philosophy is discovered or invented. I think it's
invented.
Yeah, and why is that?
Because it doesn't. So, or it could be just. I mean, I guess.
Yeah, it's just weird. Like I'm not sure. I'll have to think on that for a while.
Can you discover something that is relative?
Well, what do you mean by that?
Well, or can you discover a subjective truth? Are subjective truths discovered, or are they invented?
So it's like, is my opinion of music? That's more of a question of free will, right? Because
Yeah. It's free will. Because if you don't have free will, then they're discovered, right?
Yeah, exactly. But if I do have free will, then it's invented, right? I think that's a good point. Yeah, because like you said, subjectivity. You and me may not like the same music. That's subjective. But is it my choice to not like that music, or do I naturally not like that music? Because if I naturally don't like that music, then that's not free will, right? That's just my own natural affinity. I have no say over that. But if I choose to like that music, that's a different thing. That is free will, right?
I mean, if I could choose to like mayonnaise, I would.
Yeah, exactly. But yeah, so but I also don't know, because like you said, that's subjective. I can't tell you if that's discovered or invented for you, because you're your own person. Like you have to discover that for yourself. I can't tell you that, because how would I know? I'm not you. I'm me. I have my own. I like mayonnaise, but do I choose to like mayonnaise, or was it? And I even think, I feel like it's a weird mixture.
I also think, because you brought up earlier that inventions are invented and math is discovered, right? But at the same time, we discovered the laws of thermodynamics, right?
Right.
We didn't invent them because we didn't create the universe.
Right. Yeah, and that's another argument that I use for the discovery of it, right? It's like the laws of thermodynamics qualitatively, like if I'm just saying it verbally, those are just based off of like common sense, right? It's like, okay, yeah, one of the laws of thermodynamics is that hotter temperatures will flow into colder temperatures and not the other way around. It's like, yeah, that makes sense from our intuition of that. But it just so happens that the math that Newton discovered 400 some years ago still works on these new branches of physics that we're discovering today. It's like, if we just invented that, there's no way that it could have like survived to the extent at which it is now, because there's no way that Newton could have seen how far it was going to get us now, used in so many different applications. We've put people's lives on it with math. One, like you have the math of biology, and then you have the chemistry of biology, and then that gives pharmaceutical companies, right? Medicine is based in math. It's kind of a stretch to say, but like it's like biology is based on chemistry is based on physics is based on math, right? It's this weird like hierarchy. But it's like there's no way that Newton inventing calculus would be able to send us to the moon, Yeah. And I mean, even like they found that Newton even had like his theory of gravitation, there's gravity, and that was wrong. But it was only wrong because he was using the math wrong. They used his same math to get the theory of gravitation that we have now. He just looked at it the wrong way, He just interpreted his own writing the wrong way.
We did say it was unorganized.
Very, yeah. It's a very difficult read. I've tried and I did not get anywhere with it. But Leibniz is very easy to read.
Yeah, so. He just stayed in his 10 by 10 room for years on end.
Yeah, but that goes back to what I was saying a couple of minutes ago about like concepts exist in this abstract form. He knew exactly what he was trying to say. He just didn't do a very good job at writing it down. Like it's essentially almost the same thing as like trying to describe like a color to you. It's like, I don't know if your red is the same as my red. I have this concept of red that exists in my head, but there's no way that I could possibly describe to you my red. He just did his best, but he just didn't do a very good job at it. Well, actually, he did a very good job at it because people were able to interpret it to get us where we are. But for like the general people who were reading it, no, not a good.
Yeah, I guess language is one of the largest barriers that we have.
Yeah.
Do you think so? So we discovered mathematics, right? Do you think we'll ever discover something else that we don't even know about yet that will help us measure reality?
Well, I mean, that's what discovering is, right?
Yeah.
It's like we don't know it's there until we discover it, right?
Yeah.
Yeah. We didn't know like PDEs, partial differential equations. We didn't know that those were there until we started looking into the math of it. And then we realized, oh, these things are here, these exist. And these PDEs, these partial differential equations that were found also perfectly model the universe and how it works. And we can still use these. Like, there's no way that that was just invented and that just so happened to happen. It's like, no, we found that. It was always there hiding in the math. We just had to look at it in the right way.
Yeah, I guess I think a lot of times with this, with these mathematical concepts, the notation needs to catch up with us first before we can even find out how to do it.
And that's one of the hardest things about like new mathematicians who are discovering new math, right? But there's not a notation to put it. I mean, that's what Leibniz and Newton struggled with, right?
Yeah.
They're like, oh, I have this integral. I'm trying to talk about the area under the curve of a graph, right? We don't have a notation or a word for it that explains it right now. So I'll just have to make my own and hope that that sticks and hope that by convention people will use that.
I guess I'll just draw a squiggly line.
Exactly. And that's why I say that notation without a doubt is man-made, right? I mean, for people listening to this, an integral sign is pretty much just a big S. That's what it looks like, right? But if I was making it, I could have made it be the sigma sign, you know? I could have made it be literally anything. Yeah, it could be a squiggle. And if it caught on, then that's what people would use. There's a lot of things that, a lot of notation in math that's just used by convention, but we don't really need to use it. When I'm talking about like an algebra problem, like 3x equals 7, what is x? X can be anything. I can draw a little picture of an acorn, and it can still be the same question, you know?
Mm-hmm. Yeah, I know this homework assignment for PDE.
Yeah.
One of my variables, I just had a smiley face.
Yeah.
Like, whatever.
I saw a math meme a while ago. It was an ordinary differential equation, not a partial differential equation. And they were trying to solve it using separation of variables. Like, you know, a simple way to solve it. But for all of the new like variables he needed to bring in, he used pictures of like acorns and trees and cars and houses. And he answered the question and the equation he got, he just wrote all those in. And the teacher wrote on it, he's like, technically, yes. Like, yes, this works, but never do this again because it was horrible to read. Which is like, yeah, that makes sense, right? But yeah, it's just notation. It's like, that's just what we agree on. Like, if tomorrow we all agreed to use pictures of acorns instead of X's, that's just how it is.
So I think do you think have you heard of Elon Musk's like neural link?
I've heard of it, but I don't really know much about it. I haven't looked into it. From my understanding, it's essentially just like uploading your consciousness to the cloud, right? Is that what it is?
Maybe in the future, in like 300 years or something. But right now, it's more so it'll be able to simulate parts of your brain. Like, for instance, if you were blind, it would be able to stimulate the part of your brain that allows you to see your, I think it's called the occipital lobe. No, that's your...
I couldn't tell you. I'm not a biologist.
Yeah, whatever. But anyways, then it'll allow you to see. Right?
Okay.
Or people that have seizures, it'll be able to stimulate that part of your brain that's causing you to have seizures, and it'll control it to cause you not to have seizures.
Interesting. So it's making cyborgs, pretty much.
Yeah.
Yeah.
But hopefully in the future that'll allow us to essentially share our thoughts with other people, so there isn't a language barrier. You could just completely feel how that other person feels and like understand how they understand something.
And that's an interesting point, right? Mm-hmm. It's like, well, also if you kind of abstract that a little bit, from what I understand from what you're saying, it's like, oh yeah, if I can't see the color blue, I can put in this little thing that makes me see the color blue, or stops me from having seizures, or has me do any of this. It's like maybe like reinvigorates a sense of smell that you lost, you know? What if we put enough of those together and simulated a brain? Would it be its own consciousness at that point, or would it still just be a piece of hardware? Like I think that's an interesting question. But then that also dives into what you said about like transferring thoughts. It's like, what is a thought really? It's like a thought is this, like I said, it's like this abstract form that we have in our mind. but our minds are physiological. They exist physically. They follow physical laws, right? It's like my brain is still just a piece of jello, really. And it follows those laws. But somehow in the chaos of all the little neurons firing, I'm able to have an imagination and think, So it's like, how would we send that across, We would just have to send like electrical signals, But somehow, how do I know that your electrical signals will work the same as mine? And I mean, there's probably an answer to that in biology that they've looked into. I don't know. Like I said, I'm not a biologist. I don't read biology papers, so.
My only problem with the whole sending your thoughts to other people is that it might take away some novelty from thinking, because when I read something and I know that I'm not understanding the concept the same as the person that wrote the book, but I do take it in a certain way where I come up with my own novel idea, and then I can write about it in a different way.
Yeah. But yeah, it's an interesting point. I'm not.
Because if I were to understand, like for instance, what I just read was Fear and Trembling, right?
What's that?
It's a book by Soren Kierkegaard. It's his like grand essay about the philosophy of faith, essentially.
Okay.
And I mean, I'm not a Christian, but he is, and it's a very interesting book. And I kind of took it to mean, oh yeah, you should. The power of belief is very real.
Yeah.
If you believe in something, but if he were to put his thoughts into my brain, then all of a sudden I'd probably think of it in the same way that he does. And so instead of thinking of it as, oh, belief is powerful, belief's awesome, instead I'd think of it as, oh, I should believe in the Christian God without a doubt.
Well, at that point, though, it's like let's just play with that idea for a second. So if you had already read the book and then got his thought on it, it would be a combination of yours and his, right?
Yeah.
If you were just sleeping and I were to put this Neuralink in your head and then just send it to what it is, like cause that kind of like, Inception like idea, that would be completely different, I think the novelty would still remain, because on top of all your experiences and your personal beliefs and like your thoughts that has brought you to believe whatever it is you believe, then you hear someone else's thought on that. It's essentially the same as just reading another good book, But it's just a mixture of that and yours. It's like, yeah, now you just understand his point a lot better, but it's still mixed with what you already believe, I think the novelty will still be there. It's
Okay.
It's this objective thing mixed with all your subjective things, and that makes it novel. That makes it unique,
Cool.
Yeah, it's an interesting concept.
So do you think there'll ever come a time when, do you think our brains will ever not even be good enough, not even be advanced enough to understand some concepts?
That's an interesting question, and actually one that I was talking to someone about last night. Is there something you just can't understand?
Yeah.
Is there something you just can't? I don't think so.
You don't think so?
No. Well, okay. I don't know. So,
I mean, a chimpanzee can't understand what a pillow is.
or do they? But we don't know what a chimpanzee's mind actually is, right?
I guess they understand a pillow in a different way that we do.
Yeah. Well, exactly. So it's like whatever world we
We don't have
exist in.
language.
Yeah, whatever world we exist, like think of a fish too. If you want to even strip it down to its very basic level, a fish is almost as basic as we can get. I mean, like clearly there are microorganisms that have like proto brains and proto nervous systems, and then you can get even further down there. But I mean, like on the macro scale, let's just talk about a fish, right? Very basic creature. But they only know the ocean, right? That's all that they see. There's no need for them to think about what's going on land, right? Because they haven't seen that yet. They haven't interacted with it yet. So there's no reason for their brain to evolve to perceive that, right?
But what is a tree?
Yeah. But I think with us, the only things that we can't understand are things that we don't interact with, right? And if we don't interact with it, is that really part of our reality? Is it really real,
Yeah.
So I think anything that we can interact with, we can understand in time. We may not understand it now, like dark matter. We know it's there. We don't understand it yet, but we know it's there. And we know it's real because it interacts with things. It has this interaction with it. But I mean, there could be like these, like 4-dimensional beings looking down on us, like one in this room, but we wouldn't know because it's not interacting with anything, So how would that even be real? Like, we probably can't understand that, but
so like a being that could go beyond physical reality.
well, I mean, yeah, like what if you became a like, and I guess is like a thing with ghosts, right? Like, but what if you became a ghost, or if you want to say that just like this clump of energy that didn't interact with anything, you could just go through walls and sit in a room invisible with a bunch of other people. Would you be real to them? Like, would they know that you're real?
That's kind of like the like when you go in front of a slug and then you wave your hand, it has no idea that you're even there.
Well, I think the slug might like sense the light difference or something, but I don't think it'll be like, oh, whatever. It really only, like, the slug will only really care if you like touch it, right? Because then it's like, predator,
Yeah.
But I think humans have kind of like gotten past that point. I mean, we're looking at stars that are 13 billion years old, It's like we've kind of gotten past that point. So I think anything that really exists in our world we can understand. I think it's just when we start to talk about like things outside of this world that we just don't really understand.
The fourth dimension.
Yeah, exactly, or anything like that. It's like I don't think we can understand that. We don't interact with that. Or I mean, some people say we do. That's your own personal theory at that point. That's your belief.
Yeah.
But I'm not 100% sure if I agree with my own answer. But I think that we can understand anything that we interact with.
Okay.
Given time and
if
brain power.
We can interact with it, right?
Yeah, exactly. I mean, like, there could be this new type of star or like astral body out in the cosmos that we've never seen before. We've never interacted with it. It could be real, but to us it's not because we haven't seen it, right? We haven't interacted with it. We don't know what it is. So it's like, well, clearly we don't understand that right now.
Like with dark energy and dark matter, let's say we could never even see it or interact with it or measure it because nothing in this physical universe would allow us to measure it other than gravity. Yeah.
So it's like, right. would it really be there though? It's like there could be a million dark energy things out there that don't interact with us. So are they real? And if they are real, how can we verify that it's real? And if there's just one of them, how do we know that there's not 2 or 3 or infinitely many of them, right?
Wow.
Yeah, we don't know. And how could we know?
Yeah, I guess this all kind of ties into epistemology. Do you know what?
Yeah, how the philosophy of how we think.
Yeah, just like how do we know what we know?
Yeah.
Is it possible to know?
I took Bryce Blankenship's Belief in Reality. Yeah, and I really liked listening to that podcast that you did with him.
Oh, yeah.
Because he brought up a lot of points in there that he also talked about in class. And I remember even you talking about like Ishmael, and I was like, hey, I read that book.
It's a good book.
It is a very good book. I loved it. Really changed how I saw a lot of things for a while. But yeah, like Bryce, he gave me an assignment, and it literally was that question: how do we know what we know? And so I wrote it down, and he gave it back. And to this day, this comment still bugs me because I really don't know how to answer it. He's like, okay, but how do we know this? Like, how do we really know this? I'm like, I don't know. I don't know how we know, but we know,
Yeah. Well, yeah, I guess it's because like you don't know for certain that anything exists outside of your own head.
Right. And that's what I believe. Other people would argue that, but that's a very Descartesian philosophy. It's like, to me, my reality is anything that I've like perceived. Yeah, it is exactly what you said.
Well, that's where belief comes in. There's some things that you can't know for certain, but
yeah. Oh, I see where you're getting.
With that said, you just gotta believe it.
Yeah, right? Exactly. So it's like if I was born and raised in a single room my entire life and I never saw the outside world, would I believe that there is something outside of this room? And that goes back. You can abstract that a little bit to talk about what I just said a couple of minutes ago about like there could be thousands of dark energies out there, but we don't interact it. But do we believe that there's something out there? And I mean, and then you get into your religion. It's like, well, maybe those forces are a god or something else or whatever. And it's like, well, we really don't know, right?
Well, let's find out.
Yeah, yeah.
Well, if there isn't belief, because if you were to say, yeah, the only thing that I know is that I know nothing at all.
Well, that's something that you know.
Yeah, but that's something that you know, so technically you're wrong because you
you
might
do
not
know
even
something.
know that.
Yeah.
You might actually know stuff, you just don't even know that you know things.
Yeah.
Right?
Well, one of my one thing that I like to one of my theories is kind of about like humans in general is like so you have like the philosophies of human nature, right? And all of these theories about like these logical systems that humans follow, right? And I don't think any of them are right. To me personally, my theory is that humans are illogical to like
To an
at
extent.
a certain level. I mean, clearly we follow some logic, right?
Mm-hmm.
I mean, I stab you. Logically, you're not gonna like that, and I know, and I have a pretty good idea how you'd react if I were to stab you. So there's some logic that you follow there, but at a
die.
yeah, or you'd get very mad and stab me back, right? Like I can predict that. But at a certain level, like when you get to a soul or your consciousness, I don't think that that is logical. And clearly that drives what we do, like as people, right? My consciousness, my thoughts, how I'm having this podcast right now. I don't think that is logical, which is like, so I really say it's like, I don't think that there's a theory, like one true theory for human nature, but that itself is a theory of human nature, right?
Yeah.
And the only way that I justify that is like, well, humans are illogical, so of course my argument for that's going to be illogical, right? Like that's a logical. I'm still trying to put a logical argument to human reality, like to human nature, but it's stupid to try to prove something that's illogical with logic. It's illogical. You cannot prove it with logic. So of course you're going to run into contradictions. Of course you're going to get like illogicalities in there and paradoxes. Like, yeah, it's illogical. That's just how it is. Yeah.
I guess sometimes you need to put some questions aside so you can move forward and tackle some easier questions.
Like, what do you mean?
Like, if we use the example of, oh, yeah, like, I have no idea if anything's real outside of my body, so, like, why would I even question anything else, right? What's the point? Nothing's real. But then you could also say, well, I'm just going to trust that everything is real, and even if it's not real, I'm just going to work with the reality that I have and
exactly
and try to figure it out.
Yeah. So one like consequence of like the Descartesian philosophy that I personally live by, it's like, so at the end of the day, the only thing that you can truly be sure of is yourself, your own existence. Even if we don't live in this physical world, maybe we live in a computer simulation, at least I exist in that computer simulation. I exist somewhere in space, in time, or whatever. And like when I say space, I don't just mean like physical space. I mean like the abstracted realm of whatever it is we're from, Like that can be anything. I just choose to believe, and this is the question, do I choose to believe this or am I naturally drawn to this? That we live in a physical world that's 13.8 billion years old and follows the laws of physics, right? It's like, but where do those laws of physics come from? And then that's a whole another story. Yeah, but I believe that the world that I see, I believe you're real, but I don't know if you're real, It's like, I don't know if your consciousness is real. Otherwise, if I did know, I would be you, but I'm not you, I'm me.
Wow.
Yeah, I really like jumping back to that point because I really believe that. And actually that philosophy really, like, I really started to truly internalize that in Bryce's class because he kept asking these questions and all these questions. I remember he talked to you about the where's my body?
Yeah.
The
Daniel Dennett.
Oh, I loved that. That was a very good discussion that we had in class, and that's where I was really like solid. Where like, yeah, I believe that, like, well, because one of the things in there, he talks about like his brain. He has his brain, his own thoughts, but then they back it up into a computer, and at a certain point, he can like switch between the computer brain and his brain, and they're perfectly in sync. But at one point, he switches it, and they're different. Like he switches it to the computer or whatever, and the computer's like, "Oh, thank God! Like now I can finally talk. Now I'm not like covered by that person."
Yeah.
Well, it's like I think that in this abstract sense that the computer is its own soul, like it's its own consciousness, but it has its own unique experiences as a computer rather than a biological being that drives it to divert away from him. That's what I believe. Or do I believe that, or am I drawn to that? That's free will. That's there's so many like questions that you can keep going.
Well, you believe it, but it might not be your choice to believe it.
How do you mean? That's very paradoxical, isn't it? Isn't a belief something that isn't a choice? Like, well, it's like you why do you believe it in the first place, right? Is because you think it's right. It's like, oh, this explains my objective reality, right? Something that I don't have a choice about.
Oh, I get it now.
What?
No, I mean, that's like the thought that comes into your head when you start to believe something.
Yeah, exactly.
You know?
I don't know.
That happens to me all the time. I'll have some thought. I'll be like, oh, wow, that it all makes sense. And then a few weeks later, I'm like, oh, that actually doesn't like really make a whole lot of sense. And then I'll think about it a little longer, and then I'll believe something else.
Well, that's yeah, exactly. But that's the beauty of reflecting upon a concept. And this is one thing that I think it was Kant who talked a lot about. I don't know. It was one of the famous like fundamental metaphysical philosophers. They talked about like after every experience that you have, you need to have time to reflect upon it, and that's what builds into your to your reality. Like one example is like, so you think of like someone who's brain dead in a hospital, right? Their brain doesn't function. They can still like experience external stimuli. Like this is very cruel, but you can still stab a brain dead person, but can they reflect upon that experience? And I like one of the answers like, no, they can't, because they can't think anymore. So they don't like reflect upon that. And so they're no longer creating any more unique experiences. Right. Wow. So it's like you read the Bible or something, and then the second that you finish reading the Bible, now the reflection period starts on it. You've already gotten all the information, but now it'll start to internalize and sit with you for a while, and then you'll have your own thoughts, whether you're like walking around, and then you start to think about it. And this reflection is very important. And the same thing happens with me and math. It's like I'll learn something one day, but I might not understand it until 3 months later, Yeah. That happened with my proofs class a lot last semester. The stuff that we learned at the very beginning of the class, I didn't understand until the very end of the class, because that was just the reflection, like the amount of reflection that I needed to have on that. So it's like any experience you have, you need to reflect upon it. And that's what will build into like your unique character,
I know when I took Calculus 3, it's three-dimensional calculus. I started looking at the world in a totally different way.
Oh, yeah. Calc 3 is beautiful. I love it. It's so good.
It's like three-dimensional calculus. I had no idea that they even had such a thing.
Exactly. It's like, but then after learning it and you reflect upon it, you're like, oh, this makes sense, right? It's like, of course we need calculus to describe 3 dimensions because we live in 3 dimensions, 3 spatial dimensions. And it's like, oh, this makes a lot of sense. And even then with Calc 3, it's like, yeah, you do learn it in 3 dimensions, but you can even abstract it farther into higher dimensions. You can do 5-dimensional calculus too, It's just this jump between 2D and 3D that's hard.
Wow.
Yeah. But Calc 3 is beautiful. It's got talking about notation. Calc 3 has some beautiful notation. Partial derivative symbols. Oh, ooh, love them.
So to a sense, we almost have to have a faith in that math works, right?
Yeah, that is true.
Because we have to agree on the symbols that we use. We have to agree on the notation.
Convention, yeah.
But there are certain things in math that we don't have to agree on at the same time.
Like, what do you mean? Like, what's an example?
Well, we have to agree on the symbols, right?
Right.
But if we're using the same symbols, then you'll get to the same answer no matter what.
Yeah, or even if you're using different symbols, but you agree that they mean the same thing, you'll get to the same thing, right? Mm-hmm. Yeah, so instead of writing 1 + 1 = 2, I could write acorn plus acorn equals apple. As long as we both agree that acorn equals 1 and apple equals 2, right? Mm-hmm. As long as we both agree on that, we'll arrive at the same.
Yeah.
Yeah, and that's why I think and that's what I said before, if society is completely destroyed, completely wiped out, we're gone, the next wave of people that come up, they'll still find the same thing. Theirs will just look completely different. And that's one of the arguments. It's like, I think if we find like an intelligent, and intelligence is, an interesting term in and of itself, but if we find a society that also has their form of calculus, it'll look completely different from ours. I guarantee it. It would be very unlikely if they were also using the Leibniz integral notation to describe an integral, right? They would have something completely different. We would just have to figure out what they're saying, and they would have to figure out what we're saying. But it's the same thing with language, right?
Yeah.
Yeah.
Well, but also all of our inventions and all of our laws of physics, all of our laws of motion, everything has to work with our mathematical system.
Yeah, exactly. But the way that you kind of phrase that there, it's almost like we have to force them to work with our mathematical system. I think they already do.
But
yeah.
You have to discover
how they really
work.
It's like I know that like with a coffee maker, It all pretty much came into existence at the same time, and I don't know what like the little microchip in there does, but I have to just kind of look at how the entire thing works, and then I'm like I could look at the coffee pot too, like the pot of coffee itself. It's like I'm not sure what this does until I look at the entire picture, and then I'm able to like figure out. It's like, oh, this is how it fits in here. This is its place. It already existed with the coffee machine. I just have to know how to use it. Same thing with the laws of thermodynamics or something like that. It's like they're already there. We just had to figure out where in math that they really like fit in.
Yeah. Why does my coffee cup go cold?
Yeah, exactly. And it's like, oh, well, that's thermodynamics, which can be described through math that already is there. We just have to figure out how it is. And actually, a really funny thing is like one of the biggest concepts in quantum mechanics is like the wave function. And I'm not going to get too deep into it, but on the surface level, kind of like popular science explanation of it, it's like, well, everything exists in this like particle wave duality. And I mean, this is really like, it doesn't capture the whole essence. It's just easy to explain this way. But like an electron is both a particle and a wave. And it's like, well, what does that mean? Who knows? Like it's weird. But the equation that talks about that is a partial differential equation called Schrodinger's equation. And when Schrodinger, I love Schrodinger, and when he found out about that equation, when he discovered it, he literally was looking at like a basic equation in physics. I don't remember which one, but he just like changed one of the signs on it. He did a basic algebraic trick, and because of the algebraic trick, he was able to follow down all the consequences until he got to the Schrodinger equation. He discovered it was always there. He was just the one who discovered the little algebraic trick he had to do. It could have been anyone else. It could have been you. It could have been me. But he was the one who did it. He's the one who discovered it. It was always there. We just had to find it.
For the record, it could not have been me.
It definitely cannot be me. No. But he was the one who did it. So,
wow.
Yeah.
All right. Well, I think that's it.
Yeah.
Cool. Thanks for coming on. That was awesome. I think there are so many things just with physics that, for one, people should know.
Yeah.
And for two, just the ethical applications, but also the epistemological applications of physics.
Yeah, and the metaphysical like interpretations of it. Yeah, like what does physics really say about our universe and how we exist? Yeah. Well, thanks for having me on.
Yeah, no problem. And for you out there, if you want to make any suggestions for people to come on the podcast, or even just things for me to research, just email into.the.absurd@gmail.com. All right, there you go.